But I use the word and, because when you have something like this, it means that you are in between them. So this value is in between minus 10 and 6. So while it is greater than minus 10, it is less than 6. So this means that minus 10 is less than or equal to 2x plus 3, and 2x plus 3 is less than 6. Now let's bring this to the other side. So let's be serious now. Okay, if I tell you that A is less than B, that means that B is greater than A. So if minus 10 is less than this term, then it means that this term, 2x plus 3, is greater than or equal to minus 10. So it's okay, we've not done anything serious. It's just a simple protocol. And this says 2x plus 3 is less than 6. We're going to make x a subject of the formula in the two of them. So we're going to see what their solutions are, and we can plot a number line solution to that. How do we make x a subject? Again, same thing like we do all the time. 2x subtract 3 from both sides is minus 10 minus 3. 2x is greater than or equal to minus 13. Now you're dividing both sides by a positive number 2, so the sign does not change. It's still greater than or equal to minus 13 over 2, which is actually minus 6.5. And what's the solution for this? Well, 2x less than 6 minus 3, that's 2x less than 3, so x will be less than 3 over 2. Now, this is a negative number, and that's a positive number. Makes sense, doesn't it? So this is the number line. You've got minus 13 over 2 on this side, and you've got 3 over 2 on that side. And this tells you that it should be less than 3 over 2 and greater than minus 6.5, greater than or equal to. Means that this position is part of the solution. So you're going to shade this dot as well. Now greater than means go to the right. Less than this means don't shade it because it's not equal to it, but go to the left and keep going till you get to this guy, and that tells you the end has been met. So this is a solution to that compound problem. And something else very important, 2x plus 5 less than 4, or 3x minus 6 greater than 12. Okay, I'm going to say something now before I carry on. I forgot to tell you something. One way to represent your solution is the number line. Another way to represent the solution, which looks like a number line, is called a set notation. Now, the set notation could also be given as an answer even when you've drawn your number line, but it tells clearly what the boundaries are for x. And I'll quickly show you what that means for the ones we've solved. Greater than minus 2 tells you that in this problem, we're going to look at the set notation. The set notation, okay, for the solution in this problem is that minus 2 down to positive infinity, because this goes to positive infinity, right? So it means that it goes from minus 2 to positive infinity. Minus 2 is not included in the solution, so we put parentheses. If minus 2 were included, we'll put a square bracket. But infinity has no end, so you are not in a position to tell us that infinity is included in the solution. So you put a parenthesis as well. So wherever you've got infinity or negative infinity, always put a parenthesis because no one knows where that is. But minus 2, as far as we're concerned, is not part of the solution. In this case, it goes from 7 over 2 downwards to negative infinity. And always this is whatever is on the left and this is whatever is on the right. So in this case, the set notation for this problem, it stops. Oh, what did I just do? Guess what? This is part of the solution, isn't it? Less than or equal to. So it's going to be a square bracket, 7 over 2. And minus infinity, no one knows where that is, so it's not going to be a square bracket, but parentheses. In this problem, it is x less than minus 5. So it means that it goes from minus infinity up to minus 5. Oh, sorry, I should have put a minus here. No one told me. Okay, so